Alright everybody, today's lesson is dividing fractions and mixed numbers, and the first thing I want us to do today is just to try a problem to see where we're at. So first problem that we're going to do is to take 40 and I want you to divide it by a half, and then I want you to add 10 to it. So everybody go ahead and pause the video and see if you can do that. Okay, so 40 divided by a half plus 10, and when I ask people to do this, most of the time what they do is this, okay? When they start working on this and they do 40 divided by a half, they say that that is 20, and then they add 10 to it and say that the final answer is 30. Okay? What I'm going to tell you right now is that that's a wrong answer, because when we're dividing fractions, there's a trick that we need to do here, and it's not, okay, when you take 40 divided by half, it's not 20, because 40 divided by 2 is 20. It's like saying if you have 40 apples in front of you and you decide to cut each of the apples in half. Well, now how many apples do you have? Okay, well you have 80, because you have 80 pieces now, because each one got split into 2 pieces. So when you're dividing by fractions, what ends up happening is this. You have to take that 40, but whenever you see the dividing by a fraction, there's something that's going to happen today. We're going to change the division to multiplication, and then the 1/2, we're just going to flip it upside down to make it 2 over 1, which we know is just 2, and then we still have to add the 10. So now it becomes 40 times 2, which is 80, and 80 plus 10 equals 90. Okay? There's our final answer. So, listen, here's our rule for today. I'm going to go ahead and write it down. And here's what the rule says. It says when dividing fractions, you actually multiply by the reciprocal. And I'm going to underline the word reciprocal. Okay, reciprocal is what I did with the 1/2 here. When we took it from 1/2 and we switched it and made it into 2. Okay, that's what a reciprocal is. So if I give you some examples here, okay, if I take 1/2 and I flip it upside down and make it 1/2, 1/2, flip upside down, make it 2 over 1. The 2 over 1 is what I call a reciprocal. And you can do that with any fraction. If I take 2/3, okay, if I want to make it its reciprocal, okay, I'm going to flip it upside down and make it 3 over 2. That's also a reciprocal. Okay, if I have something like 11 over 8, okay, the reciprocal of 11 over 8, you just flip it around, okay, and make it 8 over 11 would be its reciprocal. Even if you have a whole number like 5. Well, think about what we did with whole numbers when we were multiplying. The first thing we had to do was take that whole number and put it over 1. So I'd first have to put it over 1, and then I can flip it and make it 1/5. Okay? One last thing is if I had a number like 2 1/3, what if it was a mixed number? Okay, well, you don't just flip it and make it 2 and 3 over 1. Okay, that's not what we do. What we do is we have to do this when we make it improper. 3 times 2 is 6. 6 plus 1 is 7/3. And then I can make it its reciprocal, which is 3 over 7. Okay? Right there. Another name also for a reciprocal, just to throw it out there for you, is called a multiplicative inverse. Okay? Means the exact same thing as what reciprocal does, but basically taking your fraction and you're flipping it upside down. Okay, let's do a couple here. So, example 1, we're going to do 5/9 divided by 2/3. Now, before we dive in and do this, okay, the first thing I want to point out is this. This is a division problem. It is not a multiplication problem. So even though I know the diagonals here, the 5 and the 3, really I can't reduce that anyways, but because this is a division problem, I'm not allowed to do that yet. The only time I can ever cross-reduce is when it's a multiplication problem. So this is division. Now here's really our rules. It's going to be the same thing as multiplication, except I'm going to teach you 3 words today, which are going to be, we are going to leave it, we are going to change it, and then we are going to flip it. Leave it, change it, flip it. And if we can remember those 3 directions, it's going to help us solve all of our division problems. And here's what it means. Okay, so for example 1, when I'm doing 5/9 divided by 2/3, what I'm going to do is always rewrite it. And I'm going to say these 3 things. And I go in order. I'm going to do the 5/9, then division, then the 2/3. And I'm going to say these terms. Leave it, change it, flip it. Okay, so what I start with here, let me get rid of these lines. I start with the 5/9, and my first direction is to leave it. So the 5/9 I leave alone. Okay, on to the division. I change it to a multiplication. And then the 2/3, we flip it. So it becomes 3 over 2. So again, 5/9 we leave it. The division, we change it to multiplication. The 2/3, we flip it and make it 3 over 2. And we do that anytime that we see a division problem. And what ends up happening is I end up getting this multiplication problem. Now that it's a multiplication problem, now I do everything that I did when we learned multiplication, which means I can reduce now. All right, the 3 and the 9. Divide them by 3, I get a 1 and a 3. Okay, the 5 and the 2 I can't do anything with. So multiply the numerators. 5 times 1 is 5. Denominators, 3 times 2 is 6. I check to see if it can be reduced or simplified. It's already in simplest form. So that answer is 5/6. Okay, example 2. I'm going to let you guys do this on your own, but I want you to go through the steps, which is to the 5/6 we leave it, the division we change it, the 7/9 we flip it, and then we do the multiplication problem. So go ahead and do that. Pause the video. Okay, we're back. Here's what we should have done. The 5/6, we leave it. The division, we change it to multiplication. 7/9, we flip it to 9 over 7. Now look to reduce. I see the 6 and the 9 can both be divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. 5 and 7 are both good, so now I multiply. Numerators, 5 times 3 is 15. Denominators, 2 times 7 is 14. And then simplify. Well, this is improper. I know that the 14 can go in the 15 once, and that gives me 14, so I need one more to get to the 15. Denominator stays the same, 1 and 1/14. Okay, 2/7 divided by 4. Okay, again, we learned a little trick to deal with whole numbers, like the whole number 4, when we did our multiplying lesson. So whole number 4, any whole number can be written as a fraction simply by making it a fraction by putting it over 1. So now the problem is 2/7 divided by 4 over 1. Okay, I see the division. That tells me to follow my rules, which is to leave it, change it, division becomes multiplication, the 4 over 1 I flip it. So again, always I see a division, that tells me to leave it, change it, flip it. Try to reduce the 2 and the 4. I can do this now because I made it multiplication. That's when I know I can reduce. 2 and 4 become 1 and 2, and I multiply across. 1 times 1 is 1, 7 times 2 is 14. And there we go, 1/14. Here's one for you to try. Okay, I'm going to do one thing for you here first to get you started. The 21 I'm going to write over 1. So this is 21 over 1 divided by, and I'm going to make this improper. 2 times 3 is 6, plus 1 is 7 over 2. Now when I rewrite this, notice that it's still division. Okay, I didn't do any leave it, change it, flip it stuff yet. I still have to do that. All I did was write the whole number over 1, and 3.5 I made improper. Now what you have to do is go ahead and do the leave it, change it, flip it, and then finish the problem. So go ahead, pause the video, finish up. Okay, we're back. So after we change everything into the form that we wanted in, now I have to do leave it, change it, so the division becomes multiplication, and the 7 over 2, we flip it, and it becomes 2 over 7. Now that it's multiplication, I look to reduce. 7 and 21 can both be divided by 7 to make it 3 and 1. In the numerator, 3 times 2 is 6. Denominator is over 1, and 6 over 1 can be simplified to make it 6. I really can't stress enough, guys, in this part of the problem. When I change it, okay, when I write it over 1 and the mixed number becomes a 2, an improper fraction, you got to remember that this is still a division problem right here. We haven't done any leave it, change it, flip it yet. You still have to take that step. Okay, last one. Problem of the day. See if you can try this on your own. Pause the video. Okay, you're back. Hopefully the first thing that everybody did here was change these mixed numbers into improper fractions. 4 times 8 is 32, plus 3 is 35 over 4. Now I'm not doing any leave it, change it, flip it, so it's still division. 8 times 2 is 16, plus 5 is 21 over 8. All I did was rewrite the mixed numbers into improper fractions. Okay, so it's still division. Now I got it in the form I want. Now we can do leave it, change it, flip it. So the 35 over 4 that's a bad 35. I'm going to rewrite that. 35 over 4. I'm going to leave it. The division, I change it to multiplication. 21 over 8, we flip it and make it 8 over 21. Okay, I hope you tried to reduce. I see a couple of them. 4 and 8 can become 1 and 2. 35 and 21 here can both be divided by 7. So 21 divided by 7 is 3. 35 divided by 7 is 5. And now I can multiply on top. 5 times 2 is 10. 1 times 3 is 3. Okay, that's improper. I need to make it back into a mixed number. 3 goes into 10 3 times. That gives me 9, so I still need 1 extra. Denominator stays the same. That's about as hard as they come, guys. So that's if you did that one, then you probably understand today's lesson. All right, good luck.